Okay.
Okay, first thing, could I ask you to say your full name, first and last, the spelling and your title, please?
Yeah, okay. Slobodan Simonovic, Slobodan Simonovic. I am Professor Emeritus at the Department of Civil and Environmental Engineering at the Western University, and also serving as an adjunct professor because I'm still involved with the research and advice of the postdocs and things like that.
Okay, let's just jump in to this Canada-wide map there that has come into our attention, and why was the research done for it, and what does it include?
Okay, approximately 2015, we got the collaborative research project supported by NSERC and Chaucer Syndicates. That's a large reinsurance company, to look into kind of linking hazards, exposures, and risks across different hazards, multiple hazards. I was in charge of the principal investigator, and also I was doing the work related to flooding. We had also some work done on earthquakes as well as wind. So within that particular project, the kind of number of things were surfacing: lack of unified methodology for mapping flooding across the country, lack of kind of methods to include the climate change into this type of work. And so that kind of motivated and also developed the scope for the work that we've been doing since then. And we developed the methodology. For the first time, that methodology is available for the whole country. It's looking the country in a kind of grid format, 1 by 1 kilometer size, and is utilizing historical information as well as the very recent climate projections to develop the floodplain maps, including inundation, flood risk in the form of the water depth, as well as the kind of frequency of these events. So with a number of emission scenarios, with number of these climate models, we kind of integrated that, used the so-called the camouflage hydrodynamic model, requiring supercomputing capabilities, and then did the calculation, developed the maps. And then I asked the question, okay, what are we going to do with the maps? Professionals working in this field can benefit by sharing the data or sharing the maps with them. But I wanted a little bit of more kind of public attention in a way of trying to first, share the information, bring the awareness of, how serious is the potentially flooding in Canada, and also link to the current moment where the governments in Glasgow are talking about reducing emissions, which are directly kind of affecting, what we are showing on this map. By reducing, emissions, you're changing potentially the, global temperature affecting, the moisture, precipitation, and precipitation resulting then in flood events. So I thought this is a good moment. We developed this kind of sophisticated interface that allows you to basically view all these different maps. For the maps developed for the current situation, maps developed for the near future, 2020 to 2060, and the far future between 2060 and 2100. We did develop these future maps for 2 emission scenarios, assuming some kind of middle path as well as one extreme emission path.
What are some of the most concerning results that you had found in this?
Okay, so the kind of three important aspects came out of looking the final results, comparing different maps, and kind of summarizing all the work. First one is that it became very clear that certain areas are at higher risk than others. So we were able very easily now to see across the country examples, Fraser in your area, Lower Mackenzie in your Northwest Territories, Assiniboine Red in Manitoba, and so on, are very clearly coming out as the more risky area, or areas of higher risk that probably deserve much more detailed mapping and attention than this particular effort. The second finding was that we are seeing increase in inundation area, the basic area that will be under the water, in the kind of future climate conditions. We are seeing increase in risk measured by the flood depth, and we are seeing also change in frequency, increase in frequency of this very rare events. And these increases are extremely significant for this extreme emission scenario. The changes of inundation are going up to 30%. The changes in depth up to 60%, and change in frequency obviously depends on the location. I can tell you for London, Ontario, that we are kind of seeing that 100-year flood may become a 35-year flood. That means occurring much more frequently. That's these are the kind of key findings directly observable from the maps. But we were also able to add some additional information, like overlay, for example, the population density, because now we have this for the whole country, and assess, how many people are living in, like, let's say, in flood-prone areas. And for these different scenarios, the figures are showing up to 4 million people in Canada being exposed seriously to potential flooding.
So, worst case outcomes then is, if not, the trends continue without much change, parts of, in our case, the lower mainland surrounding the Fraser River are in danger then? Is that?
Yes. Yeah.
Yeah, and so maybe can you expand a little bit on that and what people need to sort of consider?
Okay. There's some there's some technical issues, but also there are some limitations, obviously, of the tool in the current form. The kind of key technical issue is understanding that in order to cover the whole Canada, the spatial resolution is important, and 1 by 1 kilometer is relatively fine resolution when you look at 10 million kilometers squares of Canadian land. But it's not sufficient to exactly answer the questions, what buildings and streets in Surrey will be, under the water, with the coming flood, 100-year flood under this climate scenario. So that's one important message. And another is that tool currently covers only the riverine flooding. So we were looking only the rivers. And the coastal flooding, which is serious on West Coast, East Coast, Northern, also is the kind of next step of our work. Because in the coastal areas, you have the integrated impact of river flows and inundations combined with the tides and sea level rise and so on. That tool is currently not covering that.
I guess a lot of people do think about, there was a recent article done about famous cities that may be underwater in the future. And a lot of people associate that with oceans. But I guess your research, and this does show that rivers pose a risk too, because I think a lot of people do in fact oversee that.
Yeah. Yeah, that's true. And I think what you can see if you browse a little bit through the maps that are available within this tool, you will see that the rivers are creating, pretty serious conditions, or can potentially create pretty serious conditions. It is also important to mention that extreme precipitation is also creating the specific type of flooding within the urban areas, and that's also not part of the mapping that's done here. So yes, there are different sources and different sources of flooding that are of importance in Canada. What this tool does, it's representing what are the potential impacts of rivers and extreme climate conditions that may affect the flows within the rivers in our country.
Can you say, can you link the two for us, if between rising temperature and climate change and how it would lead to rising water levels in rivers, Canadian rivers?
Yeah, that's okay. That's done by basically climate modelers, and mostly climate models, especially the climate models of the most recent report prepared for the IPCC. These models are very sophisticated tools that are including not only the processes that are occurring in the atmosphere and the interaction between the land surface and atmosphere, and as well as oceans and so on, but they're also including some hydrologic processes, how the precipitation is transformed into runoff and providing this runoff information. That's exactly what we were using. So there is a direct link basically between the emissions and the change of the global temperature. I mean, this last report that was prepared for the IPCC and issued in August is presenting even the equation that kind of directly relates the level of emissions represented by the set of so-called shared socioeconomic scenarios, basically pathways of the future development, and the temperature. And there is almost kind of a linear link, which is clearly indicating with the continuation of serious emissions of the greenhouse gases is directly related to the temperature. Temperature, we know from the physics, is directly related to kind of precipitation, moisture, and what I was talking about, hydrological part, then transformation of that precipitation into runoff and flow that can be, when it's large, overflowing the land and creating damage.
If you were to tell anyone on the street what message does your research into this particularly give to Canadians and people everywhere?
Yeah, okay, but there are kind of number of messages that you can take out of this work, and one message is that we need to be fully aware that the risk of flooding is increasing across the country. There are variations from location to location, but the risk is on the kind of increase. That is already kind of creating a follow-up requirement that we need to look into very seriously into the regulations, land use regulations, for example, where the future development should be allowed. We have to avoid the potential areas that may be inundated under the future conditions. The kind of third message will be, okay, so for the already existing infrastructure, we need to look into more local measures that should be improving the infiltration, reducing as much as possible the impact on paving and creating the parking lot, streets, and so on, by introducing some green areas in between that can accept the water, increase the infiltration, reduce the flood peaks, delay the timing of the flood peaks, and so on. So looking into structural as well as the non-structural options. It is important also to mention that quite often we are ignoring this fact that the only way to deal with the very large floods, extreme events, we need storage. We need to move the water somewhere. I mean, Winnipeg in Manitoba is a very good example of very sophisticated infrastructure, which is using the floodway to take the water around the city, using the diversions to take the portion of the water to the lakes, using the reservoir on the tributary to kind of store the water during the peak flows. So creating that storage, finding that storage, and having that storage available, I think is something that almost every area, every place, every watershed that we touched needs to consider.
Okay, so now I want to just get your kind of guidance through this website. So if I have, actually, maybe I can screen share with you here quickly. Just let me see.
I can screen share and you can tell me what you want to do.
Actually, yeah, let's get you to screen share then. How about that? That way you can go and just, take me on a tour of the website.
Okay.
Okay, go ahead. And maybe if you could go down to the Lower Mainland, that would be nice.
Okay. Okay, just a second. Too many things on the screen.
Mm-hmm.
I was talking to too many people and demonstrating tons of stuff. And okay, yeah. So I hope you can see now the map. This is the kind of entrance point into the tool, which is obviously presenting this is the Google map. There is also opportunity to see that map in a different form using this kind of OpenStreet format, and that kind of allows a very detailed view. If you kind of zoom in, you can see the details of the different kind of locations and so on. Let's look at the kind of Vancouver. I'll go back to the Google image, and obviously we can zoom in into the areas, and the tool allows, as you can see on the top, the number of different access points. If you are interested directly to explore the maps, you can click and select explore the maps, and then move into this right-hand side and select the maps that you are going to show. We are also providing, because the methodology that's used is original, and I think it's required in order to understand what the maps are showing. So we have, the kind of project information, a little bit on the methodology, the definition, what different maps that are available are, and what periods they're covering, what inputs they're using. How are the maps created, step-by-step kind of description, sources of data that's being used in kind of developing the maps, and also some basic stuff, and what I call the frequently asked questions, where you can define what the 100-year flood is, what the SSP or the shared socio-economic pathway scenario is, and so on. We also provide some references. These are technical papers, technical documents, which are published on the methodology and on the use of the tool. We also provide, under this question mark, the kind of user guide. This is the walk through the kind of system, how you move from the entrance screen to the other screens, select and present the maps and options that are available. The contact information, and obviously now the most important part, presentation of the of the maps. We have a set of general maps here. These are basically the digital elevations, so high resolution and lower resolution. We have a boundaries of the drainage basins, the main drainage basins in Canada. And on the request of the insurers, we included also the overlay with the postal codes, so that you can relatively easily locate within which postal code, particular areas or particular flooding is occurring. So, like if you kind of select the digital elevation model, it will be immediately kind of overlaid. If you would like to find out the information just by clicking at your location, you get the coordinates, you get the elevation, you get the detailed data. There is a couple of legends here. One for the water levels. We will actually revisit that when I put some of the flood maps. And also this is the legend for the digital elevation model, which is basically describing what's the meaning of different colors in this map. Okay, so these are these basic maps. Let me show you also, I can show you the postal code map, and you can see how basically detailed is that presentation. It takes some time to render the map. It's possible that the internet is overloaded
Yeah.
in my neighborhood at this time,
Yeah.
8 o'clock.
Yeah.
Anyhow, so basically you can kind of really zoom
Yeah.
in and see each postal code area. When you start kind of looking into flood maps that are generated, we have first a couple of options for, I forgot to mention that basically there are two return periods that are considered 100 and 200 years. And for these two return periods, the flood maps are developed. The current condition maps are these four maps, the first two for 100-year and the second two for the 200-year maps. And they are developed in two different ways. The one map is developed using the observations and so-called the reanalysis products, which are kind of interpolating the observations across the large territory or across the country. And the second map is developed by using the current climate models for the historical period. So we are using these sophisticated tools that are developed basically to project the climate in the future, and running that on the historical period between 1980 and 2020. So these are the kind of two current condition maps. And if you kind of look at I can select one of them, let's say 100-year map, and now you will see the map is going to show over the it's extremely slow. I'm really surprised. Okay, so here are the kind of inundated areas. You see now that different shades of blue are indicating the kind of water depth. We have opportunity here to kind of create the transparency, so you can basically through the water see the areas that are being inundated. If you kind of click on a particular area, you will get the kind of coordinates, you will get the indication what map you are looking, and you will get the information on the water depth, which is basically the shade of blue. And this is the way of showing these current condition maps for 100 and 200 years. and also very similar way of showing the maps for the future conditions. Now, for the future conditions, we have a little bit more information because we did, as I pointed out, look into 2 different time periods, to 2260 and 2100. And for each of them, we developed the 100-year and 200-year maps. And for each of them, we tested and developed maps for 2 different emission scenarios. The emission scenarios we selected are from the last report for the IPCC, and we use the kind of mid-range emissions that would consider to some kind of response of the governments similar to what is going on right now in the future. And also we looked at more kind of critical emission scenario where really less will be done and the warming will continue, resulting in a more critical.
Can you take me to that scenario and show me what would happen?
Okay, let's say we look at the 100-year scenario. We look at the this is the scenario that is looking to far future, 2060 to 2100 for the mid-range emissions. That's SSP, SSP2. And if you're interested in a particular location, we were mostly analyzing all the data, the extent of inundation and everything. If you are interested in a particular location, you should be kind of clicking on the same location, comparing the water depth to the situation that you were shown with the current conditions. So that allows you to kind of compare possibly the difference. Then you can, if you want, you can kind of look at this map will be that most critical if you're interested, again for the period 260 to 2100, and that will be showing more areas, I think, under the flood, and you see the darker blue obviously indicating the higher the higher flood risk.
So what happens?
Sorry.
What happens to the areas underneath blue there? Like what would it look like realistically in this SSP5 and in between 2061 and 2100? If you're underneath that blue, what realistically does it look like in real life?
You will be under the water.
And is that realistically full time, or is this in case of a flood event?
Okay, you have to understand what is a 100-year and 200-year flood. What we are showing is the particular probabilistic condition, and that condition means if the flood occurs of that intensity that corresponds to the flood of probability 1 in 100, that is going to be the inundation at that particular location. So. Okay. What we have done, when you run the hydrodynamic model, you generate the flood inundation information, you generate the depths, and you generate velocity, and then you do the statistical analysis of all this information. That's because you have a period now between 2020 and 2060. You do the statistical analysis, you develop the distribution function, you fit the distribution function to the data, and then you find out the flow that corresponds to the probability of 1 in 100 or 1 in 200.
Yeah. So once that, once in a century flood hits, this would be the damage and the probability.
Yeah, it's very important, because some people are mixing and, let's say I have information from the flood from 2017 and, let me see what the difference is. Be careful. I mean, comparison of the 2017 flood event with the 100-year flood may not be, this is like apples and oranges. You need to know what the return period of that, flood event is in order to kind of compare. So we are clearly showing the 100-year and 200-year return period floods. That's it.
The 2017 flooding in British Columbia, was that at all close to a once in 100 year or no?
I am not. I
Yeah.
can find that information for you. I'm
Yeah,
not,
I can look at it. Okay, just curious if you had it off the top of your head.
I'm not sure. You know, today I had another interview and they were testing me, my knowledge of the Montreal, 2017 and 19.
Okay, well, that's good. Thank you for that general walk through the
Okay.
website. I appreciate it. And that's all the questions I had. And yeah, well, I'll follow you, your work going forward. And it's definitely of interest now after this particular tool.
Okay. Tell me, are you going to do something with this, or can you at least let me know if you do something?
I will let you know, how we treat this on the news. It's I'm gonna have to meet with someone and figure out how to make it visual and understandable for a TV audience. But it's definitely interesting, and I think I have the sense from you of exactly what it means. I'll email you a follow up either way.
Okay, thank you very much.
You. Have a great night.
Yeah, our university is also interested. So there is a person who is for the communication, and I will share your name with him also. So when you send the information to me, that they can be also informed about that.
Thank you. Yeah, that's great. Okay, perfect.